Let me know if I'm audible, guys. So just let me know if I'm audible. So I've just corrected that. Let me know if I'm audible. Let me know if I'm audible. Apologies, I think there was some issues earlier and I did not see that. So, okay, anyways, I was saying about what is the agenda for today. So we'll be talking about, we are pretty much into data science live and we are into, uh, uh, data analysis in 3 weeks. That's what session. So we're talking about Python pandas. So in pandas, in today's discussion, we'll be talking about two major things. So we'll be covering the remaining functions which we have so far, and also on top of that, we'll be covering Pandas strings. Okay, so there are string computations on Pandas as well. That's what pretty much the agenda says. Okay, so we'll be talking about those two things today, and we'll try to cover a few questions if time permits as well. Okay. But again, as you know, it's pretty much a live session, so I'm monitoring my chat, and thank you so much, Vasanta, for confirming that I was not audible. So that pretty much we saved our time. Otherwise, I would have to repeat again anything. So great. So before starting, I'll introduce myself. My name is Arpit Jain, and I'm a lead data scientist myself. I have 9 years of industry experience into multiple domains, and I'm also a motivational speaker. So I take industry sessions. I talk to students regarding their job, career placement. So anything in general. If you want to talk about data science, Python, or even the simple topics regarding their job, career, do put up a question in the chat box, and I'll try to answer them to the best of my knowledge. Okay. So that's pretty much what my introduction says. So I'll just quickly jump into the content without wasting much time. Do let me know if my screen is so visible to you guys. Yeah, great. So I hope my screen is pretty much visible, right? So we were discussing about other Python functions the previous day. So today we'll be discussing few more detailed analytical functions available in Pandas. So there are something called as if you want to do a table wise operation, if you want to do a row or a column wise operation, or we want to do an element wise operation. So we have a data frame now. So on the data frame, we can perform the action for each of the individual elements, or we want to perform an operation on the entire row or a column, or we can also perform the element table wise, the entire table itself, right? So for that, we have three different functions available: pipe, and we have apply, and we have apply map. Okay, so these three are very interesting functions available. Okay, so I'll show you the functionalities of these three individual functions and how and when to use these functions. Okay, so just be patient with that. So I'll first take the pipe function, so which is giving me a more of a table wise operation. So now here I have again created the same data frame. So I have four different columns here: ONE, TWO, THREE, and FOUR. So 1, 2, 3, 4. That's basically my four different columns, and I have the indices of my different rows. And respective values are given. So 1, 10, 100,000. So like by 220, 200,000. So that's going to be my values of individual rows I have, right? Now, what I'm doing is, the objective is I want to add 2 to all of my elements. So basically, I want to add 2 to all of my elements of my table. So I want, for example, the column 1, the first element 1. So that has to be added by 2, so it should become 3. Likewise, 2 should become 4, 3 should become 5, 4 should become 6. So I'm doing plus 2 in all the elements. Likewise, for 10, it should be 12, 100, it should be 102, 3000, it should be 3002. So all the elements of my table has to be added by 2. Okay, so what I've done, and likewise I can do a subtraction also. I can subtract the value. So what I want is all of my elements of my table has to undergo the same operation, the same mathematical operation, or even in that sense, whatever I want to perform, right? So whether it's a mathematical or any other thing. Okay, so depending on what operation I want to perform, this is what I want to do here. So in this case, I have the first function I've created, add to. Okay, so it's a user defined function which I've created. So in this case, what I'm doing, returning n plus m. Okay, so I'm just adding up the values n and m here. Okay, very same thing. So now in this case, what I'm doing is I'm actually, kind of creating addition. So what I'm calling this function is, so look at this. So I'm here, what I'm doing is I'm passing the values. So I'm in the function dot pipe. I'm actually, what I'm doing is I'm cascading what function I have to apply. So what do I exactly want to perform on this data frame? So what I want to do is add 2. So I want to call this function add 2 on top of my entire data frame, okay? And what I want to do add 2 on, so here I'm also passing the argument m, which is 10. So I want 10 to be added on top of my entire data frame. So this is my objective is, okay? And also I've created the function add to, which is actually expecting n and m, right? So in n and m, so I have the first argument of df, and on this df, I'm passing 10. So this is basically what I want to perform, right? So this is how I should be adding it. So now once you see, if I do df of pipe 10, now we can you see this? So 1 became 11, 10 became 20, and 100 became 110. Likewise, all the elements is now added with 10, right? As simple as that. So this is what my addition says in terms of the values of my data. Okay, so this is what my pipe does. So again, pipe is a cascading information. Okay, so now as you know, so on now this is my updated data frame, right? So now on this updated data frame, what if I want to remove, I want to subtract 5. So now I want to subtract 5 on top of this. So always remember, it's a cascading information. So it's not like on the original data set, I want to perform subtraction of 5. No, I want to perform subtraction of 5 on top of this, on the top of the output of this data. Okay, I can obviously do that. So how can I do that? So I'm just calling again a dot pipe function on top of this entire computed data frame. Okay, so what I've done is I've just added dot pipe on top of this new exit on and the existing computed data frame. Okay, so now what will happen in this case, if you see, so it will first add 10 and then subtract 5. So now here you can see 1 plus 10 was 15, and now 1 plus 10 is 11, and 11 minus 5 is 6 I have here. Okay, likewise for 10 it is 10 plus 10 20, 20 minus 5 15. So like this, my updated data frame would be coming here. Okay, so we can always cascade this application of dot pipe. So dot pipe is a sequential operator. I can keep on adding the functionality which we want to add on top of my data frame here. Okay, that's pretty much possible. Cool. So that's what we have from the df pipe operation. The second is the apply operation. Okay, so what does apply do? So apply, as I said, it's more of a application on top of my individual rows or columns. Okay, so now what I want to do is I want to do some manipulation on top of the entire row or entire column. Okay, so I don't want to perform on the entire data set, but on the one or the other of the column or the row. So row wise operation or a column wise operation. Okay, so now look at this, for example. So I have this entire data frame. So now, okay, this is a data frame which I've created. Now suppose I want to what I want to do is I want the mean of all the columns. So what I want the mean of all the columns I have. Okay, so by default, what I can do is I can do the apply. So df dot apply. So what I'm applying to all the different columns. I have default is my axis 1, which is my columns here, and I'm applying np dot mean here. Okay, so I'm applying that what is the mean of all of my columns I have. So I can simply use df dot apply and np dot mean. So it is applying this function np dot mean to all the individual columns, which is 1, 2, and 3, and 4 in my data frame, and I'll be getting the output. Okay, as simple as that. So this is how it works. Also on top of this, what I can do is I can do some complex operation also. So for example, what I want is I want to find the range of my values. Okay, so I want to find the range of my values. So what I want in this case, I want what is the difference between the maximum and the minimum values. Okay, so what I want is I want to see how my individual maximum and the minimum values look like. So basically I'm trying to find out the range of my values here. So can you see this? So what I'm doing is for each of my individual columns, I want to pass what is the range. So x of max function minus x of min, and I'm passing it over lambda. So you know that, right? So lambda is a unanimous function. We've already seen lambda. So we can pass lambda like basically anywhere. So depending on wherever it is fitting in, right? So this is where it comes. So df dot apply lambda of x, x of max minus x of min, right? So you can pretty much do that. So now here in this case, what we'll be getting, so x of max is 4 in this case, respective to this particular column, and min is 1. So 4 minus 1 is 3. I'll be getting 3 here. Likewise for the column 2 and for the column 3 and for column 4, I'll be getting the respective differences of my maximum and the minimum value. So the range of my values. So what I want again, and I'm applying this function. the range calculation on top of my every column with whatever I have. So this is again doing a row or a column wise operation here, guys. Clear? Making sense? This is where apply is getting used. Great. So also we have what we can do is we can pretty much use on top of one of the other columns also. So suppose I only want this expression to be passed on one of the columns here, right? So now look at this. So now what will happen? So just give me a second here. So what is df.1? So df.1 is 1, 2, 3, and 4, right? Now if I'm passing dot apply np dot mean here. So now look at this. What's happening? So now what is happening is here the indexes now is not the columns, right? So now it becomes rows. So can you see this? Now it becomes the indexes are actually my rows here. So what are my rows? My rows are basically my indexes, which is one. The values are 1, 2, 3, and 4. So obviously, so now if you do np.mean of 1, it will be 1 only, right? And np.mean of 2 will be 2 only. So now instead of getting the data on top of my columns, now I'm passing the same information on top of my rows, right? So the indexes are now rows. It's not columns anymore, right? So which is again pretty much possible. Okay. We have again apply map. So apply map again we are doing the element wise operation. So it's again a similar, I would say the similar concept which we have in terms of pipe. So here again we are applying df for apply map x cross 100. So if I do it like this, all of my elements are getting multiplied by 100. Okay, it's similar to pipe function only, but there is certain differences. So as you know, so I've written down the differences also. So map is element wise for series. So apply map. Apply map is element wise for data frames. Likewise, apply also works for element wise only, but it is suited for more complex operation or aggregation. So here, once you have more aggregations or certain group wise to be performed on top of like typical rows, so that's where apply is used. But element wise, apply map is used on data frames. Okay, more or less a similar thing. Okay. Moving ahead, we have another good function available, which is reindex. Okay, so we have seen reset index, but we have another very interesting thing called as reindex. Okay, so I hope you remember we have seen reset index, right? So reset index, it is resetting my index of the series element. We have seen it quite before, right? And we were passing the argument drop is equal to true. That was majorly like we were dropping the original indexes. We were not storing the original indexes, rather simply taking the new indexes. So that's where reset index is getting used. But reindex is a different concept. So let me show it to you how reindex works. So again, I'm creating the same data frame. So I have the data frame 1, 2, 3, and 4 here. Okay. So now what I want, so I here I have the indexes already. So reset index, it resets the index. Okay. And the reindex, I'm again defining a new index altogether to my data frame. Okay. So what is my default indexes here? 0, 1, 2, and 3 here, right? So now what I want, instead of 0, 1, 2, and 3, I want this new index to be given. So I want A, B for the initial two and then 0, 1 for the last two, okay? So what is the syntax looks like? So I can define the df.reindex index and also give new index here. And can you see this? I will not pass this for now, okay? So now in this reindex, I have also an argument called as columns. I can also specify the column. So basically, it's not only giving the reindex on my rows. I can also specify what columns I want. So just look at this. So in the although the new index is pretty much defined, which is for the row values, but on the columns, can you see I'm selecting 1, 3, and 5. So I don't have a 5 column in my original data set, isn't it? So I don't have a 5 column in my original data set. So what does it'll print me? Now look at this. So here in this case, can you see? So I have A, B, 0, and 1. So by default, what did it give? It has filtered out the data depending on the indexes which we have given. So although I was expecting that this reindex is going to give me is going to, I mean, kind of again replace the original indexes with the new indexes which I'm giving. But no, this is not what it does. What it does, it tries to filter out the available indexes from whatever we are passing here. So we have from the available indexes from the row out of A, B, 0, and 1, we have 0 and 1 available, right? And what is 0 and 1? That is this and this row. So I mean, these two rows are pretty much 0 and 1, right? So this is where it will be printing me the data. But on the indexes A and B, it has given nan. It is not a number. It is not defined here, right? And also same thing is pretty much applicable for the column 5. So can you see this? This entire column is pretty much empty. Can you see this? This entire column is pretty much empty here. So this is again which we have to identify. So reindex is basically giving you an objective of filtering out the data based on the available indexes, both from the rows as well as columns. Okay. Now here, as you have seen that this missing data, so when you are finally getting the data, it's a missing value, right? So NaN kind of a thing, right? So we also have an argument here, fill value. Okay. So we can also pass an argument fill value in this case to replace the missing data with whatever value I want. Okay, so for example, suppose I want this missing data to be replaced with 0, for example, okay, or I could say minus 999, for example, okay, a garbage value. I can pretty much do that. So now in this case, can you see all the missing data wherever the values was not a number, it is now replaced with a missing value or with a garbage value minus 999, okay. Also, I can do anything as you were seeing. It was earlier having a data call is missing. So I can also pass a string missing kind of a thing. If I run it like this, now I have missing printed in place of the not a number data. Okay. So pretty much possible with the reindex function we have. So what is the difference between reset index and reindex? Reset index, what it does the sequencing by resetting the row index. What it does, it again resets the row index sequence wise. Okay, that's what reset index does. But reindex, it aligns the data both for rows and columns depending on the info passed or nan elsewise, right? So whatever it does not reset, it just aligns more or less filters out the data based on the indexes which we give. Okay, and it is valid pretty much both for rows and columns. And whenever this indexes is not valid, it will give me nan elsewise. Cool. So that's pretty much what it does. So in the reindex part, so that's pretty much fine. So that's cool. Again, let's move ahead. So we have another very interesting function called as rename. Okay, so again, pretty much clear. So pretty much clear by the name itself. So a rename is pretty much what it does. It renames the values which we're trying to pass. So we can rename both the things. We can either rename the indexes or we can rename the columns names. So we can, this is the two things which we have, right? So we can rename both of them. We can rename the columns as well as the indexes as well. Okay. So what is the syntax here? So this is pretty much the syntax. Okay. So you have to pass it under the curly braces, which is more of a dictionary format. So in the dictionary format, the left hand side will be your original name and the right hand side will be your change name. So whatever you want to change this to. Okay. So for example, here I'm passing df.rename. So I'll just print df for now. So df is the original data frame 1, 2, 3, 4 and all that, right? So I'll just first remove this in place. So now here, can you see this? This what I want is this ONE1 column to be replaced with ONE underscore. So I'm just renaming to, or just simplicity sake, renaming to 5, okay, and 2 to 6. So I want 1 to be replaced with 5 and 2 to be replaced with 6. So can you say this? What is the syntax? So this is my one pair, and then I have a comma here, and then I have another pair differentiated by a colon, right? So this is pretty much what we have here. So now in the columns, what we can do is we can have this pretty much pair here, and the indexes also is pretty much fine. So this is for the columns renaming, and for the indexes, for example, here 0, 1, 2, and 3, right? So 0, I want the 0 to be replaced with A, and I want 1 to be replaced with B. So I have again here two pairs, right? So two pairs of such a renaming which I want to perform. So if I do it like this, now can you see this? My indexes 0 and 1 in the row got replaced with A and B. So this is the renaming of my indexes. And also the columns, which is 1 and 2, these got replaced with 5 and 6. Can you see this? So I have pretty much renamed the column, right? So I pretty much renamed my column here. But unfortunately, if you still print df, it'll still remain the original one. So can you see this? Although I have run this df.rename and rename the column and the row indices, but unfortunately, my original data frame still remains the same. So that has not changed, right? So that is pretty much valid because you have not saved it, right? So you have just run this, you have not saved it. So either you do this, you pass df is equal to this. So now you're saying that now this df, so you're saving this to the original data frame df. So now if you do it like this, it will pretty much stay intact. Okay, this is one way of doing this thing. Or you can still do this. So my bad. Or you can still add one argument here. So you have argument called as in place. So if you write in place is equal to true, that means that it's going to replace the original data frame and going to replace the original data frame with this modified version of the data frame. Okay, this is pretty much what it will do. Hey Vandana, good evening. Thank you so much for joining us here. Great. So now if you do it like this, if you run it, now here you will be able to see I have pretty much the things. So 5 and 6, A and B. So now this DF has changed now. Okay. So this is what it'll do. Great. Wonderful. So let me quickly go through again interesting function available on Pandas iteration. Okay, so Pandas iteration is again one of the very interesting topics, guys. One of the very interesting topics. So I mean, you can definitely iterate over the elements of Pandas. So the data frames here. There are multiple ways to iterate. So iterate means what? So you're iterating over the elements, right? So ultimately, that's what we need. So there are three different types of iterations. Okay. So the first is iter items. So you can see the spellings iter items. So here is more of a key value pair and it's a column wise operation. I'll give you the example also. Okay. The second is iter rows. So iter items is basically column wise operation. Iter rows is basically row wise operation. So here we have the indexes and the values. And the second and the third is iter tuples. Okay. So this again, I'll give you a original data as a view object. So I'll show you the differences. What do I mean by this? Okay. So for the simplicity's sake, again, I've created the same data frame, which is pretty much 1, 2, 3, and 4 here, right? Now, what I'm trying to do is I'm trying to get the elements iter item. So what does an iter item return? It returns a key and the value, okay? And what is my key here? And key is the column header for me. So the here iter items always do a column wise iteration, okay? So here key would be 1, okay? And for this one, what are my values? Values are 1, 2, 3, and 4, right? So in this case, I'll be iterating over my different column wise data and the key would become my column header and the values will become the data of such columns, right? And for every such key value pair from the df iter items, that will be 4 pairs, right? So this one pair and this is second pair, this is third pair and this is fourth pair, right? So fourth key and the value is my elements here, right? So 4 pairs I have. So for all of such pairs, print key and the values. This is what I'm trying to do. Now look at this data. Very interesting, guys. Very interesting. Okay. So now look at this. So what I'm printing the key and the value. So what is my key here? You can see this is what it is getting printed. So I have ONE1 here. So I'll just do not like this. I'll print it in a separate sentence. So print value. Okay. Now look at this. So I have print as ONE. So this is my first key. Okay. I'm printing the key here. So key is my 1, which is what? Which is my column header. So always remember iter items is giving me the iteration over columns. Okay. Over columns. So here iter items means first key would be what? The column header ONE. So this is what I'm printing here ONE. And what is the value? The data points from the column 1, right? So I have 1, 2, 3, and 4. So all the indexes of my data frame 0, 1, 2, and 3 and the values are 1, 2, 3, 4 is getting printed for my first key, which is ONE. Okay. Now I have the second key, which is TWO. So this is what I'm getting here, TWO. So in this TWO, my second key, I'll be getting the values of my second key, 10, 20, 30, and 40, right? Likewise, this is my third key, THREE. I'm getting the third key here and getting the values of my third key. Likewise, the same would be for the fourth key. Okay. So this is what pretty much my df.iter items gives. It's always very important to understand how exactly you are iterating over my different elements here, right? So iter items is giving us iteration over my columns. Remember that, guys. Okay. This is confusing. So iter items, iter rows, iter tuples, this is a slightly bit of a confusing concept, but not that tricky. But it's just like you have to remember this. Okay, so iter items is through columns, so it's a column wise operation. Iter rows is my row wise operation. I'll show it to you. How does it differ from I'll give you an example also. Okay, so this is pretty much what my iter items gives. Okay, cool. Now I can just formulate it also. So for example, what I'm doing is I'm just simply formulating it. So what I'm doing is I'm passing it as an index. So what I'm doing is print the index value as my key and the value as my value. Okay, so I'm printing, making it more clear. So now I can see this. So in fact, rather I'll not print it here. I'll just print again in the new sentence rather. Right, so I have format it and then I put it inside the square brackets. Now if I look at this, it's pretty much clear, right? So now I have the values. So index is 1, right? And because I'm printing it like this, so index and then 1, and then the value, which is like this value, and the value is the entire series I have. So 1 2 3 and 4. So same thing. So I can formulate the printers as well. Okay, so this is for my iter items, guys. Okay, now I am giving you another data frame. So just tell me the output for this. Okay, so you know this. So iter items is my column wise operation, but iter rows is my row wise operation. Now can somebody tell me, if I run this operation, for example, just simply putting it here. Okay, so now what I want for key and the value in df dot iter rows, print key and the value. So again, I'll just print, I won't print it here. I'll print rather here. Okay. So quickly, guys, can somebody tell me what will be the key here? What are my keys? So if I do iter rows, what are my keys? So remember, guys, so for iter items, there were other keys. For iter rows, will be other keys. So can somebody tell me what is the iter rows? What are the keys in iter rows? If I run it like this quickly, Vandana, Vasanta, Mahesh, whosoever is part of our chat today, quickly, what will be our keys here if I do iter rows in place of iter items? Quickly, guys. Any responses? What will be the keys here? So I'm doing it over iter rows, so not iter items. So just a quick answer, guys. Okay, meanwhile I'll just show it to you. So here, as you know, in iter items, the keys are basically my column headers, right? So what are my column headers depending on the data? So here in this case, if I do, I'll first print iter items first. Okay, so iter items. Okay, if I do iter items, so here my keys are name, age, and education, isn't it? So my keys are name, age, and education, isn't it? So these are my keys here, right? But now if I do the same data on top of my iter rows, for example, so if instead of iter items, I do iter rows. So in this case, just look at the difference. So the keys will change. Okay, so now the key becomes id1, which is the index of your row. Okay, and now this will become your data, and for that the indexes are name, age, and education. This become your indexes, and the name for id1, which is your key, is Arpit. So it's a student data. It's kind of a one row which you are getting from iter row. So all the elements of the rows are getting printed here, right? So I'm accessing individual row elements by doing iter rows. That's the difference. Okay, so this is something which we have to understand, the difference between iter rows and iter elements, iter items. Clear? Okay, so now on the same data frame, let me print df first, and then I have to show you the same data frame. If I do it over iter tuples. Okay, so now what iter tuple does, it'll create the a view element of my pandas. So it's giving you a tuple element. It's just for the view purpose. Okay, it does not, you cannot use it as it is. So it's more for the view purpose. So it's giving you a view of your data. So all the row element is being clubbed together into a pandas object, and then it is giving you the keys and the elements value. So indexes is id1, name is Arpit, age is 30, education is MTech. So this is pretty much I am getting in terms of iter tuple. So it's like a row element clubbed together and being printed on the screen. Okay, that's what iter tuple does. Great, cool, wonderful. So that's pretty much about how my iteration of my data happens. So iter rows, iter items, so iter tuples. So iter items, as you remember, just for the remembering sake. So iter items is for my columns. Iter rows is for my rows. Iter tuples is a column. It's a pandas object which I'll get as a combination of my row elements. Okay, row data. Cool. Now, another very important topic in pandas is sorting. Okay, so how does sorting happens in pandas? Okay, so sorting is again very important topic. So we'll discuss about two different ways of sorting here. So we'll use the function sorted, or we also use the function sort values. Okay, so two different ways. So we'll use both the ways. We'll see what is the differences and what are the pros and cons, and we'll see I mean, how we can choose between these two. Okay. So right now what I'm doing is I'm creating an unsorted data frame. Okay. I'll show it to you. What do I mean by unsorted? So you can see this. So I have the column 1 and the column 2. So I'll rather not print this and rather just kind of show this just a minute. Yeah. So this is my data frame, column 1 and column 2, okay? And I have the indexes. Can you see this? It is unsorted. So it is not sorted. So I have 1, 4, 6, 2, 3, 5, 6, 9. So it's a it's like a half it's like not it's not sorted, right? So the indexes are pretty much not sorted. So I've created a new data set which is pretty much a random values. By doing that, I'm figuring out what is the kind of unsorted data frame I've created. Okay, and I have two values, column 1 and column 2. Okay. So now my objective is to sort those indexes, and there could be multiple ways of sorting, maybe in ascending order, descending order, maybe a defined logic of sorting also. So many ways we can sort this data, isn't it? So now to check this information, how can we do that? So sorting is majorly done by two different ways, okay? By using the function sorted. So sorted is again a function, so we can directly call sorted on top of my data, or we can use dot sort function also. Okay, so we have the sort function pretty much. And again, we can also call the sort index or sort values. So we can also use the sort index or the sort values. I'll show you all the different things and I'll tell you how to use one of them. So first, see here, the objective is very simple. So I need to sort the indexes, right? So I need to sort the indexes. So I can directly call the function call as sort index. So if I call the sort index on top of my data frame, which is unsorted df, right? Now here in the argument, I'm passing ascending is equal to 2, which is making sense because I want to sort the data in terms of uh, pretty much the ascending order of my indexes. So I want 0, then 1, then 2, then 3 likewise. Okay, so all the indexes to be sorted in an ascending order. So if I do it like this, so now can you see this? Now pretty much my data is sorted. So 0 is here, 0 is this row, so 0.91250 and 0.61. So can you see this? The values for the 0th index is printed here, then the first index and the second index. So I'm pretty much sorting my entire data frame itself by the logic of indexes. So I'm sorting the index here. Okay, cool. That's the first way of sorting the values, the indexes. But still, the unsorted df still remains pretty much the same. Okay. Now moving ahead. Now what I want the sorting to be done based on my values. Okay, so for example, this is my data. So I'm least bothered with the indexes right now. Now what I want the sorting to be done based on the values. Okay, and values of what? Column 1. So I have an argument here by, so on which, based on which column exactly you want to sort the data. So for example here, I want to give based on the column 1. So here I want the column 1 data, the numbers. So again, I want maybe in ascending order, right? So ascending order or a descending order based on the values. So here in this sort values also, I have pretty much the argument called as ascending. So by default is true. So even if I won't give anything, it'll by default sort it in the ascending order. But I can also do it in the descending order. So if I put ascending is equal to false, that means that is going to sort the data in the descending order, right? Pretty simple as that. So here now if I solve unsorted df dot sort values by column 1, so I'm trying to sort the data based on my column 1. Okay, so now look at this, what will happen here. So now I'm just going to print this sorted df, for example. So can you see this? So this is what my sorted df looks like. So now this column 1 data is pretty much sorted now. So this is my first smallest value, the second smallest value, the third smallest value. So all the column 1 data is pretty much sorted, and likewise whatever the value of column 2 is getting printed alongside with that. Okay, so for example, you can see in the unsorted data, so for the value of 0.20, which is here, so the value of 21 is 0.218413, which is right here, right? For this, the indexes will remain the same. It's just like the values are getting sorted now, and in this case, for now, it's more of an ascending order, right? So this is what pretty much I'm trying to do with the sorted of my information. So again, important thing to note is we can see here the indexes is pretty much not making sense, isn't it? So the indexes is not making sense. Obviously, now we can call the reset index function maybe on top of this sorted data frame to see how exactly, I mean, to again reset the index based on what I want in the newer data frame, right? So we can always call this reset index on top of this, right? So if we call reset index, can you see this? By default, this is sorted now, 0, 1, 2, 3, 4. This is a new index, but also it is creating a new column index where the original indexes before after sorting got saved, right? So I can also, if you want to save the unsorted indexes, you can still save it by not giving the argument here. It'll by default save it. But if you don't want it, you can just pass the argument drop is equal to true. So in this case, it won't save the original indexing. It'll just simply reset the index here. Now you can see this, the indexes are reset. So also on the same data frame, you can pretty much call this reset index on top of this sort function also. This is also pretty much valid. So now your first, I can look at, remember guys, so in Python, it's pretty much a sequential operation, okay? So what it does for this data frame, it will first sort the values. Then on this sorted data frame, it'll again perform this action, which is dot operation of reset index. So it'll pretty much do this. So now it'll reset the index by dropping is equal to true. So let's look at this. So simply running this. Now if I call sorted df, it'll be pretty much sorted. It'll be pretty much fine. So I can always call multiple such functions by just keep on adding dot on top of all the other available or given functions which I have. Okay, cool. That's what pretty much I wanted to cover here. So also this is for my one sorted data frame. I can do the sorting similarly for multiple such columns also, right? So I can also pass multiple such columns. For example, if I want to pass the kind of I mean, if you want to sort based on multiple such columns, it is also possible. So now I want the sorting to be done based on both the columns, column 1 and column 2. So that means that here first I want to check the column 1 values. Now post that also check the column 2 values. So I can specify the list of such columns on which you want the action to be performed, and still pretty much possible. So you can always do that. So it'll do the action based on both the columns now. Okay, pretty much possible. So again, as I was saying, so we have also an option of doing the descending. So again, so how to see these functionalities, just go inside the parentheses, do a shift tab. And if you do a shift tab, you'll pretty much see the different arguments we have here, right? So for example, ascending, we have access, we have in place, and also you can see an interesting thing of kind. I'll show you that. Okay, I'll show you how to use that. So for example, in this, suppose I want it to be in the descending order. So I don't want in the ascending, I want it descending order. So I can simply write ascending is equal to false. So and that means that now I want the sorting to be done in the descending order. So now can you see this here? Then the maximum value is coming first, and then the respective smaller values are coming likewise. Okay, so I can still have it done based on the ascending or the descending also, pretty much still fine. Cool. Great. So now I want to show you the last function in sort values, which is pretty much through algorithms. Okay. So now here again, as I was showing you in this functionality, so in this you have an argument called as kind. Okay. So kind, in the kind, if you go to the documentation here, kind. Okay. So can you see this? So this is what I have here. So the default is quick sort. So the default is quick sort. But this version of Pandas which I'm using, it is supporting right now four different algorithms for sorting. Okay, so what does it support? It support quick sort, merge sort, heap sort, or stable. Okay, so four different sorting algorithms it does support, and it is pretty much a data structures concept. Okay, so if you are aware of what is merge sort, what is heap sort, what is quick sort, so you must be able to understand that. So we can also apply the algorithm on top of my sorting techniques. Is pretty much possible, and based on that technique, I can ask the compiler to sort the data based on that algorithm. Okay, so as I've said, so let me show it to you. So now, for example, suppose if you have done the kind as merge sort. Okay, so I can specify merge sorts, for example. So now the data will be sorted pretty much based on the merge sort. And also again, so we can still call dot reset index on top of it, and I can call drop is equal to true, pretty much still the same. If I do it, I can still have the indexes being reset. So this is pretty much applicable to all the things which I'm trying to do, and we can still perform the same action. Okay, so kind is giving you the argument kind is pretty much giving you that flexibility to use different algorithms on top of the sorting technique which you want to use. Okay, great, great. So I think with this, I'm pretty much done with the functions which I want to cover for Pandas. So I'm pretty much done with the different set of functions we have in Pandas. So now what we are left with, the string manipulations and then the group by operations. Okay, so string manipulations and then the group by manipulations is pretty much left out. So again, we'll meet tomorrow, same time, 10 p.m. I'll quickly cover the string operations and then I'll jump into the few exercises. Okay, so tomorrow come prepared with the concepts. As soon as I finish strings manipulation, I'll ask you a few questions to solve. Okay, so we'll do some hands-on exercise tomorrow. We'll finish strings and then we'll finish some questions on, definitely on my concepts of pandas. Great. Great, guys. So I think let's wrap up for the day. And thank you so much for being patient and staying live with me. So as for now, we'll wrap up the thing. And then tomorrow, as I've said, so we'll be starting with pandas strings manipulation. And also we'll do some exercises tomorrow. Okay, great. So with this, I'm going to give your evening back. Thank you so much for joining us. And it's such a pleasure to be part of the good people. So great, guys. Thank you so much. See you tomorrow, same time, 10 p.m. Bye-bye.